Electronic devices. All electronic circuit consists of many electronic devices. These devices serve to control the flow of electric energy as required. Electronic devices which should be studied are resistor, capacitor, inductor, diode, transistor, ICs, etc. Resistors. Resistor, abbreviation R, is a device that uses to resist the flow of electric current for both direct current and alternating current. There are several types of resistor, vary according to size, shape, resistance, and characteristic. Unit of resistance is ohm. It is divided into three types as follows. 1. Fixed value resistor is a resistor that cannot change the value itself. The value of resistance of this resistor can be read at color band on it. Symbol. 2. Variable value resistor is a resistor that can adjust the value as required depending on its specification. It's mostly used for controlling voltage in electronics circuit, such as turning down the sound in radio or television. Symbol. 3. Light-dependent resistor, LDR, is a resistor that can adjust the value by using light. The resistance depends on intensity of light received. If high intensity, the resistance of LDR becomes low. Symbol. Any resistor can generate electrical power. Electrical power in resistor occurs when current flows through a resistor. This power is measured in watt. If we use a resistor with lower power than actual power in the circuit, it could cause heat. Sometimes resistor may be burnt. In some circuits, heat is needed, such as water heater. The source of heat is from high-power resistor, which is made of nichrome wire. This power is generated by flow of electric current in the wire. But in some circuits, such as radio circuit, heat from resistor is not required. So in circuit design, the consideration of resistor is dependent on each application. Power calculation in resistor. In practical, selecting of appropriate power resistor in electric circuit is important. For example, radio use 1/4 to 1/2 watt resistor. But if 1/2 watt resistor generates heat, 1 watt resistor should be used instead. Power can be calculated as follows. P equals E times I is equal to I squared R is equal to E squared over R, which P is the power unit in watt, E is the electrical voltage, I is the current, R is the resistance. Example, 4.3 kiloohm resistors connects to a circuit which cause 1 milliampere of current flow. Find power at this resistor. P equals I squared R, which is equal to quantity 1 times 10 to the negative third squared times 4.3 times 10 to the third, which is equal to 4.3 milliwatt. Summation of resistance in circuit. In series, RT equals R1 plus R2 plus R3. In parallel, 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3. Application of resistors. From left figure, 50 ohm resistor is connected to a radio transmitter to be as a dummy load or dummy antenna. The reason to use a resistor with 50 ohm is to match impedance output of the transmitter, which is normally 50 ohm. The reason to put resistor in this circuit instead of only antenna is to prevent too strong signal from transmitter to annoy any people. The right figure shows circuit which contain 3 resistors connect to perform as an attenuator circuit. Attenuator circuit can be designed to attenuate the power as required. In figure A, this circuit will attenuate signal at input. The size of signal at output depends on the design of resistance R1, R2, R3. For example, there is a transmitter that has low transmitting power. Since the signal of this drive circuit is very high, so we can adapt the attenuator circuit to connect between drive circuit and input circuit to attenuate appropriate signal with input of transmitter. Sometimes resistor can be connected as in figure B. Suppose we want to make a circuit that requires a relay. If we have wrong spec of relay, for example, we have 6 volts relay, but in the circuit we want 28 volts relay. We can adapt 6 volts relay to use instead of 28 volts by connecting circuit as in above figure. To find the resistance of R1, we use a multimeter to measure resistance in coil of relay. After that, make a calculation. Assuming that the resistance of relay is 100 ohm, we can find R1 as follows. I equals E over R is equal to 6 over 100 is equal to 0.06 amperes. VR1 is equal to 28 minus 6 is equal to 22 volts. R1 is equal to VR1 divided by I is equal to 22 divided by 0.06 is equal to 366.67 ohms. The right figure is an application of variable value resistor to adjust voltage in range 0 to 12 volts. The right figure is the application of resistor to be as a protection device from preventing sudden current drop when turn off power supply and used to protect current from power supply when it is turned off. Capacitor. Capacitor is electronic device which store electric or discharge electric charge to circuit or other equipment. It is used to be assembled in any application. The unit of capacitance is in farad, F. There are 2 types of capacity, fixed capacitor and variable capacitor. Capacitors are widely used in electronic circuits for blocking direct current while allowing alternating current to pass. In filter networks, for smoothing the output of power supplies. For variable capacitor, capacitance can be adjusted by rotating core of capacitor. Normally, it is mostly found in radio-tuned circuits. Fixed capacity can be divided into 3 types as follows. 1. Electrolytic capacitor is cylindrical-shaped capacitor with polarity. In general, this type of capacitor can operate at voltage from 6.3 volts up to 450 volts, which is instructed on the capacitor. Connecting capacitor to circuit must be done at correct terminal, otherwise it will be damaged. Generally, long pin is positive and short pin is negative. In practical, the voltage allowance of capacitor should be double of actual operation. 2. Ceramic capacitor. This type of capacitor has no polarity. Most of them can be used in the range of 50 volts to 2000 volts. 3. Mylar capacitor. Like ceramic capacitor, this type of capacitor has no polarity. It is robust and has good moisture resistance. Main feature for this capacity is that it will hardly change the capacitance in the moisture condition. Inductor. An inductor, or reactor, is a device that can store energy in a magnetic field created by the electric current passing through it. An inductor's ability to store magnetic energy is measured by its inductance in units of Henry. Typically, an inductor is a conducting wire shaped as a coil. The loops help to create a strong magnetic field inside the coil. Inductors are one of the basic components used in electronics where current and voltage change with time due to the ability of inductors to delay and reshape alternating currents. Inductors called chokes are used as parts of filters in power supplies or can be used to block AC signals from passing through a circuit. Moreover, it can be used in tuning circuit, delay circuit, or ignition circuit in a car, etc. There are 2 types of inductor, fixed inductor and variable inductor. Symbols are shown in figure below. Inductor is a device that resists the change of current in circuit. The connections of inductor are the same as resistor in series and parallel, and also the summation of inductor. There are 3 types. 1. Air core type. 2. Ferromagnetic core or iron core type. 3. Ferrite core type. Diode. Diode is a device that's made of semiconductor. It helps to control the current flow in one direction and prevent reverse flow of current. Diode consists of 2 poles, i.e. anode, a must be connected to positive, plus, and cathode must be connected to negative, minus. If diode is connected incorrectly, it will not allow the current flow through and the appliance cannot work. Symbol of diode is as follows. Some diodes generate light when current flow through it. This kind of diode is called light emitting diode, LED. Symbol of LED as shown in figure. LED has two legs. Shorter one is cathode and longer one is anode. LED is similar to light bulb with small power consumption. It's widely used nowadays. For example, traffic light, console lighting, warning light in some appliances, computer screen, television, etc. In right figure is an application of diode in transforming AC to DC for radio receiver. Relay. Relay is an electromagnetic switch. It serves to connect or turn on a circuit. It operates by pushing or pulling a contact from one side to another, as shown in figure. In figure also shows symbols and type of relay. In figure Kokai shows normally open relay, NO. In figure Kokai shows normally closed relay, NC. Relay component consists of magnetic that is connected to wire X and Y, movable steel arm called armature, and contacts. When current flow from X and Y will cause magnetic field at magnetic. In other words, magnetic is stimulated to form magnetic field which result in pulling force to pull armature toward magnetic, which affect both types of relay as follows. Normally open relay, NO, pulling contacts to another side. Normally closed relay, NC, pushing contacts apart. If stopped stimulating magnetic by disconnecting current flow through coil, this cause no pulling force from magnetic, then spring at armature will pull armature back to position. In case of NO relay, it will push contacts to disconnect path of A and B. In case of NC relay, it will pull contacts to touch each other as ever, which will connect path A and B. Transistor. Transistor is device that made of semiconductor. There are two types of transistor application as follows. Analog circuit. Transistor is used to amplify any signal such as sound signal, radio frequency signal, voltage control, and also switching power supply in a computer, etc. Digital circuit. Transistor is used as switch to on or off only. Digital circuit such as logic gate, RAM, random access memory, microprocessor, etc. Normally, transistor has three legs, i.e. base, B, emitter, E, and collector, C. Transistor is divided into two types by structure as follows. 1. PNP transistor is a transistor that supplies power at base and lower voltage than emitter. Symbol of PNP is as follows. 2. Npn transistor is a transistor that supplies power at base and higher voltage at emitter. Symbol of NPN is as follows. Transistor is a device which is controlled by electric current at B, or called base current. That is when base current changed just a little. This caused current in E, emitter current, and current in C, collector current change. This makes transistor act as switch to on or off circuit. If there is no current flow to B, current will not flow through E and C either. It likes turning off switch, open circuit. But if just small amount of current flow to B, we can control more current pass through transistor to E and pass to other device that is connected to C. Vocabulary: accordance, cause, component, part, fluctuation, interrupt, disturb, intensity, instead. Integrated circuit. Integrated circuit means a circuit that combines diodes, transistors, resistors, capacitor, and others together in a small device. At present, IC is made of small silicon called chip. Inside the chip consists of lots of small circuit. There are a lot of logic gate grouped together as a very complicated circuit, such as microprocessor, that is used to control electronics appliance, such as computer, mobile phone. Random access memory is a type of IC that is very important nowadays. Advantages of IC are IC will combine several complicated circuits as a circuit. This makes electronic appliances smaller and lighter. The circuit inside will be separated as blocks. Each block has own function. Circuit in each block will then grouped easily by connecting each block together. This makes less wire connection, less soldering, and reducing fault in manufacturing process.